Be a review of our basic nomenclature. Compounds, we have two types of compounds. We have ionic and we have covalent. I'll start with covalent. Covalent is between nonmetals. Okay, they are the sharing of electrons. All right. We actually use prefixes to indicate how many atoms of each element we have. So, for instance, CO, we would call that carbon. Oops. C-A-R-B-O-N, sorry. Carbon monoxide. Okay. The first element gets a prefix if there's more than one. The second element always gets a prefix. This would be called sulfur. Hexafluoride. Okay. And then we have, let's see, this would be called tetrasulfur, tetranitride. Okay. We also, whenever you see the name of a compound, go to a few examples. Say you have chlorine monoxide. No, this would be 13A. Chlorine monoxide. The prefix tells you how many. So you have chlorine, you have no prefix, so that means there's one. And you have oxygen, has mono as a prefix, so that means you get one. You could have silicon dioxide. Silicon is Si, there's no prefix, sorry, so it's 1, and then oxide, O, that di means 2, silicon dioxide. And that's how you do covalent, right? With ionic, and I'm going to actually start a new page, it's a little bit complicated, so we have ionic. Ionic is actually between a cation and an anion. And that cation is formed when it loses electrons, and that's normally your metals. And an anion is formed by gaining electrons, and that's normally your nonmetals. Okay. Or you could have an ionic compound if you have a polyatomic ion. Okay. All right, so how do we name these ions? All right, if it's a cation, it's a metal. You'd write the name of the element. But you want to be careful. Some metals can have different oxidation numbers, which would require them to have Roman numerals. Now the ones that require Roman numerals would be, let me write this out, they can vary their oxidation number, their charge. That would include your transition metals, and tin, antimony, lead, and bismuth. They would require Roman numerals. There is an exception transition metals that do not require Roman numeral is zinc. It always has a +2 charge. Cadmium always has a +2 charge. And silver always has a +1 charge. So you would not use Roman numerals with them. Okay. Bis and anion tends to be your nonmetals. The way that you name them is you drop some of the name and you add the ending IDE to it. Okay. All right, some examples of that would be for ionic, you could have NaCl. This is a metal. So you would just write the name of that metal. You need to check if it's a transition metal or one of the 4 exceptions, and it's not. Sodium is not, so you'd write sodium. And then you have Cl, and this is a nonmetal. So you drop some of the ending and add IDE, so chlorine becomes chloride. Okay. You could have another one. This is a metal. And anytime you have a metal, you want to think, is it a transition metal or is it one of the 4? And it's not, so we can just write its name as is, aluminum. This is a nonmetal. So we would take the name, drop some of it, and add IDE. So iodine becomes iodide. I think we would have one which may have polyatomic ions in it, such as this is a metal. It is not a transition metal, and it's not one of the 4 that get Roman numerals, so we'd just write aluminum. This is a polyatomic ion. And polyatomic ions, you just write their name. So SO4 is sulfate, so you just write sulfate. This one, BaSO3, that's a metal. It's not a transition metal, and it's not one of the 4 exceptions, or one of the 4 that are not transition metals that require Roman numerals, so we'd just write its name, which is barium. And then SO3 is a polyatomic, and SO3, -2, is sulfite, so we'd write sulfite. Okay. And we can look at one, let's see, in which you would require, flip over here, to FeBr3. All right, so this is a metal. It is a transition metal. Iron is a transition metal, so it may require a Roman numeral. Then you need to see whether it's one of the exceptions that do not get a Roman numeral, and the exceptions being zinc, cadmium, and silver. So we do need a Roman numeral with that, so we'd write iron, and we're going to have to figure out what that Roman numeral is. The overall charge on a formula is always 0. We do not know what the charge is on iron, but we do know what it is on bromide. It's -1. There are 3 of them. 3 times -1 is -3. That means the overall charge on this bromide is -3. So then what number plus -3 gives you 0? And it's a +3. That's not your Roman numeral. Then you have to say that number divided by your subscript. 3 divided by this 1, understood 1 here, is 1. So that means that the 3 divided by 1 is 3. So the Roman numeral is 3. And then this is a nonmetal. So we'd drop the ending and add IDE. So that would be bromide. All right. Let's see, we have another one here. We could look at Cr2O3. All right. This is a metal. it is a transition metal, and it's not one of the exceptions, so it does need a Roman numeral, so we need to figure out what that Roman numeral is. The overall charge on the formula is 0. We don't know what the charge is on chromium, but we do know the charge on oxygen is -2. 3 times -2 is -6. So this side over here must be +6. That's not the Roman numeral. The Roman numeral is this number divided by the subscript. So 6 divided by 2 is 3. So this is going to be chromium 3. This is a nonmetal. And so that would be oxide. And I'll do another video on how to write the formulas. If you have any questions, please see me in class. Thank you.